Bonjour, hello. My name is Erez ZIMERMAN. I'm the CEO of Massivit 3D. First of all, I would like to thank Composite Exchange for having us here today, and I would like to thank everyone that came to see my presentation. Today, I'm going to show you how we can produce molds that takes usually days over days over days over weeks in few days only. So without further ado, let's have a look on our agenda and what I'm going to cover today. So I'm going to talk about Massivit, the company that I'm the CEO. I'm going to talk about specifically the Massivit 10,000, which is a specific machine, 3D printer to produce tools, molds, jigs, fixtures, and so on and so forth. We're going to talk about the materials that are being produced with our Massivit 10,000. And we're going to talk about partnering with Sika, one of the leading manufacturing companies in the world, a Swiss-based company. I'm going to talk about use cases, how our customer in Italy utilized the Massivit 10,000 for production in the automotive industry, and additional use cases that are used around the globe. And of course, I will be happy to answer any questions here on the stage, and you can meet me later on at the meeting point behind this gate. So, who is Massivit? Massivit is a company that founded in 2013 by innovators and pioneers in the 3D printing market. We have a disruptive, large-scale 3D printing or additive manufacturing technology, and our main claim to fame is the ability to produce, to print parts at least 30 times faster than any other manufacturing technique. And today I'm going to show you how we are doing it. We have more than 50 patents around the technologies, and we have more than 200 machines already installed around the globe, in Japan, in France, in Italy, in Puerto Rico, in Swiss, in the US, and many other countries in the world. And the investors that stands behind Massivit is Stratasys, which is one of the leading 3D printing companies, and Yaskawa, which is one of the leading robotic arms for the industry. Let's see a quick video that describes how the Massivit 10,000 3D printing produce molds.
The Massivit 10,000 automates tooling for composite manufacturing. This cutting-edge additive manufacturing system enables direct casting with high-performance materials to dramatically speed up tooling. Introducing the world's first isotropic 3D printed mold. The Massivit 10,000 empowers composite material manufacturers to produce custom molds, tools, mandrels, plugs, jigs, and fixtures within a matter of days instead of weeks. The Massivit 10,000 shortens your mold production workflow from 19 steps down to 4 simple steps and eliminates the need for a plug. So, how does it work? The Massivit 10,000 utilizes a dual-head system to directly print and cast molds. Based on an initial CAD design, the first head 3D prints an outer sacrificial shell at high speed. The second head intermittently casts a thermoset material into that shell as it builds. The shell is comprised of 2 thin walls made of water-breakable photopolymer material that polymerizes instantly under ultraviolet light. The thermoset material forms a solid, isotropic mold. The mold can then be post-cured in an oven to improve its mechanical properties at elevated temperatures. It is then simply immersed in a bath of plain water, causing the shell to crumble away. The Massivit 10,000 offers near-net shape casting. The mold can be post-finished manually or machined as needed. Your high-temp, high-performance isotropic mold is now ready for use within less than a week. Benefit from advanced casting materials that ensure consistent mechanical and thermal properties across all axes. Discover digital tooling for a wide range of industries including maritime, automotive, rail, defense, aerospace, sporting goods, and bathware. Join the digital revolution with the award-winning Massivit 10,000 additive tooling system, offering automated, high-speed tooling for composite manufacturing.
How our technology works, we're actually, as you've seen in the video, we take the CAD file, we print in 3D several layers, we build layer over layer over layer, and after several layers, additional head is coming that cast in between the shell material, which is epoxy base with chopped fiber and filler that gives it an enhanced mechanical properties. This process is repeatable several times. At the end of the printing process, we will see the video in a minute, we take this part, dip it in water, the walls fall apart, and then I have a final tool in my hand. This is very unique technology, and instead of, this is the final mold, I brought with me some small samples here for the demonstration. You're all welcome to our booth to see exactly the big molds that you've seen in my video, but this is a small, just to demonstrate that this is the final mold that was produced, for example, in 1 hour and 47 minutes. Now, if I want to make it in other technology, for example, CNC, I need to take a big bulk and subtract it, mill it, and create lots of waste. And actually, the usage of the Massivit 10,000 enable us to print, at least to produce molds 80% faster. We're capable to print it in large scale of 1.4 by 1.1 by 1.5 meter. This is the cubical volume. And we can print high-end materials, as you've seen in the video, that can get to an autoclave machine, can reach up to 220 Celsius degrees coming soon, and also to produce in an autoclave machine in 6 bar pressure. And as you see, this is a closed loop of the video that we just seen. We see the shell that is made of the water breakable and the casting material that is in a viscosity of a honey. This is a very unique solution, and the fact that we are casting material that is in viscosity of a honey enable us to get isotropic mold. Isotropic mold means that the mechanical properties of the molds are identical in all directions. There are alternative solutions that you build layer over layer, but then the mechanical properties is different in different angles. And also this is totally sealed for vacuum, and again, can get into an autoclave machine. So this machine enabled to print variety of materials. We already have 5 materials that can be 3D printed with the Massivit 10,000. The first one is SIM 500 that has high temperature with low CTE. Additional material that we have called SIM 84 that has American standard called ASTM E84 certification that can fit to a theme park and entertainment environment. We have partnering with Sika, co-developing special materials that can be used and being introduced today here at JSC. You can see it in our stand. We can print material that up to 120 Celsius degrees. This one also filled with aluminum particle that has good thermal conductivity. We have material that is good for room temperature as an entry point, as a excellent value, cost effective. This is for room temperature, and in the future we'll have additional materials coming down the road. So just to give you the use cases of this machine, can be used for prototyping if I need one part only. It can be used also for tooling, like open mold, closed mold, jigs, fixtures, sacrificial cores, plugs, master, and of course for custom manufacturing for end-use parts. The use cases are enormous. For example, open mold. I will see some pictures and images of what we are doing. Reactive injection molding, sacrificial tooling, rapid prototyping, custom manufacturing. Here we can see an example of open mold. This is a car seat that was printed in 42 hours only. Again, to have a mold for a car seat to have it from A to Z, all included, less than 5 days. This is another example. All these use cases, you are welcome to come to our booth and see it in your eyes. This is an example of a bike fairing. This is example of our customer called Novation Tech. He's also presenting here. I will give you all the booth information in my last slides. But you can see again a mold that we produce for an high-end car seat, again, less than 1 week.
The Massivit 10,000 is something completely new. It was the first time that we saw something that was at least 5 years ahead compared to the technology we saw in the market. That's why we sat it down the same day and we decided to buy the machine. 90% of our business is focused on automotive. And we're talking about the sporting goods and especially luxury sporting goods for cars. All the major brands you may know that are also racing the Formula 1. In order to provide something unique, you have to be able and flexible enough to produce carbon fiber components for serious production, but fully customized. And we are talking about handcrafted components, which means that most of the job are done by hand. We are unique right now in our market in Europe, especially because we have multi-location. We work here in Italy, we work in Hungary, and Croatia. In the past, we had an outsourcing procedure to get the master produced by a third-party supplier. Now, with Massivit, we are able to produce in-house the master. And the target is to produce everything in-house. Having the production in-house means that you have no secrets, no confidential information which are provided outside. You use epoxy resin, raw material. Nobody else is using epoxy resin. The same resin we use for the components, the same resin we use for the molds, which is fantastic because it's a precise material and it's really strong. Strong enough to be cooked with the master and the lamination into the autoclave. The top priority now in the market is the time to market. So the time reduction for every new sample, for every production is crucial. Thanks to the Massivit 10,000, we are able to produce the master in a couple of days and then to produce the first tool and the prototype in a couple of weeks. That's the reason why we are getting more and more orders from our customers. That's why we're getting more projects. That's why we're growing 30% per year.
So what we have seen in the video, our customer Novation Tech that is located in Italy, utilizing our machine to produce molds for the automotive industry for companies like Ferrari, BMW, Aston Martin, and others. Reactive injection molding, if you want to make cushioning or polyurethane-based parts, we can print with the same material and do, for example, this seat cushioning. We can do something that is very, very unique. For example, if I want to create this inlet, air inlet, if you look carefully, although I will try to make it more in the light, if we look carefully on the geometry of this part, it cannot be produced in normal molding techniques. It's very, very complicated. And with our technology, we can take the same water-breakable material that we printed. Now it's totally hollow inside. We wrap the carbon fiber or fiberglass on this sacrificial tool. We dip it in water like we seen in the video. This actually crumbles away. It falls apart. And then I have a part that cannot be produced. You can look carefully on the geometry. And again, you are all welcome to see bigger parts that was produced in this sacrificial tool. Very, very unique and can create any shape without limitation of tooling design. Rapid prototyping. For example, before I go to manufacturing, we all know that you always need series number 1. You always need only one part to validate the engineering or the design behind it. So this machine can be used for rapid prototyping. For example, this is one of our customers in Italy that produce electrical car. So before we go into design, and we all know that after you finishing the R&D, you move to manufacturing and everything needs to be validated properly. So here you can print literally full car, and that was full car. You can see the hood, the door, the bumper. Everything was printed full car size, less than 2 weeks. This is another example from our customer in France. This is a custom car that was 3D printed, again, less than 2 hours. You can see how this use case was done in our YouTube channel at Massivit in YouTube. And custom manufacturing, all kinds of parts that you need only one copy or one part, you can 3D print it. This is an example from Alstom Group, the train company, produced by our customer Stratiform in France. You can print this train bumper, and you can see how long it took to print, 16 hours, and there's no need for storage. The big benefit here is not only the printing, but you don't need to prepare spare parts on the shelf. You can store all your files in the cloud, and once you need a spare part, you just can print it overnight and install it on a train. Again, speed, size, and materials, and these are the three main benefits that you can get from a Massivit 3D printer. Another example, I invite all of you to come to our booth and see how all the nice things that I explained implemented in this bike that was printed on our machine called Massivit 10,000G. For example, if I need rapid prototyping of this chassis, will take 12 hours only. If I need the fuel tank, again, fuel tank, you will see the geometry. You cannot produce it in mold. So this is a sacrificial tool that was printed in 9 hours only. The cushioning of the bike was done in the rim, reactive injection molding, and the tail of the bike was in an RTM mold that again printed in 6 hours only. And you can get some ballpark figure how fast you can bring to market, on one hand, validation for your design, and on the other hand, also manufacturing tools to produce the final parts in your production line. So just to wrap up my presentation, and then I will be happy to address questions. So this is the Massivit 10,000G that we are showing here at JEC, and it serves for prototyping, tooling, and customized manufacturing. And the main benefits for our customers that own our machine is the ability to print parts, tools, molds, jigs, fixtures 80% faster than any other printing technology. Big volume, 1.4 by 1.1 by 1.5. This is the cubical volume that can produce parts. And we have selection of 5 materials. Some of them are with our partnering with Sika that some of you may know in the market. So this is the presentation about Massivit and the usage of the Massivit 10,000G. You are all welcome to visit us at Hall 6, booth number D41. And our customer also that presenting here, the company name is Novation Tech, and they are in the same hall, but they are in booth E71, very nearby. And you can see some of these big molds are in our booth, and also some of the parts that are in our customer that called Novation Tech. If anyone have any questions, I will be happy to address, and then we can meet later on in the meeting point. Feel free to ask any questions. I know you are all amazed with this machine and this technology, but take another minute and I'm here to address any question. Yes, you have any question?
Yeah. Are your 5 materials able to address specific needs? For instance, electrical box containing electronics inside for EMC performances and so on.
You mean to print like an electrical cabinet?
Yeah, exactly.
I suggest that we will sit in our booth and I will understand exactly what is the needs and what is the specification that you're asking on the emission of electrical, that's what you mean?
Yeah, exactly.
I will be happy to suit you to one-on-one and you know, get a little bit some sizing and wall thickness and get into the details. But theoretically, this can be done. But we need to understand exactly your specifications.
Are you offering only 5 materials?
Currently, we have 5 materials, and we can see which one can suit to your specific need.
Okay. Thank
Then,
you.
gentlemen, I had another question.
Hello?
Yes?
The question is, do you have any study of this machine is what is paid for getting back? So how many years that it needs to be run fully, or it's just 1 year?
That's an excellent question.
Yeah.
It really depends on the uses. As a rule of thumb, customer that produce need give and take 30 molds or tools a year. He has an ROI, let's say, of 15 months to 1 year.
Yeah, it's full-time, full-scale production, or?
Depends. It really depends on the size.
Yeah.
But this is about 50% utilization of the machine.
50%.
The machine can print double than what I mentioned, but the ROI, return on investment, is usually after when you take 30 molds in, let's say, average size of 1 meter to 70 centimeter to 60 centimeters, as a rule of thumb, 30 tools like that, you will have an ROI between 12 months and 15 months.
Okay, thank you.
Thank you. You're welcome to see it and see some big parts in our stand.
Hello.
Yes, ma'am.
Yeah, I want to ask, like you explained, like in epoxy resin you are using for making these molds. So any specific epoxy properties or requirements you are looking for?
Yes, we are printing epoxy. Some of it is our development, and some of it is with co-development with Sika. Depends on the material that we are using. Some of them has chopped fiber inside. Some of them has aluminum particles inside. Some of them has flame retardant ingredients. It really depends on the material that is needed, the temperature that is needed, the thermal conductivity that is needed. Every material that we have has a clear data sheet that actually explain in specific the mechanical properties of the material. Yes, I have another question.
Hi, hello, good morning. Thank you very much for your presentation. My question will be a little bit related with the material leftover that was on the mold, the one that was melting with the water. Considering now that you use taking action on this kind of leftovers or spillages, could you please explain a little bit if there is any kind of circular activities on these materials?
Yes.
Thank you.
So as you've seen in the video, we put the part after it comes out of the printer and the walls crumble, fall apart. They are not contaminate the water. So this is actually like a small particle of acrylic-based material. The water can remain and you can actually filter it. Take this tiny plastical part and recycle it like you recycle this bottle, for example. Like this, the particles that are fall in the water can be recycled as any plastic. Thank you. I'm happy that everyone has a question. Actually, I have 5 seconds, so I will be happy to meet everyone in the meeting point, address one-on-one questions. And of course, you're all welcome to come here in this hall 6, D41, to meet us, and I will be happy also to tour you around and show you the technology. And again, thank you to JEC for having Massivit here, and a good day to everyone.